Okay, what is shown in this example is a metal plate. Again, it's a seam plate. Okay, when you see a seam plate subjected to X, Y stresses, you will see that okay, this is a plane stress situation, right? So it's subjected to tensile stresses along X and Y direction, and the corresponding strains measured in the plates are also given. You can see the two here. These are two strain gauges. Like using them, you can measure the epsilon X and epsilon Y. And since the stresses have been known, we'll determine the Poisson ratio and the modulus of elasticity of the material. So this is the inverse problem of using generalized Hooke's law to correlate stress and strain, since all stresses and strains have been given. Okay. So using the Hooke's law, we have two directions. Right? You can calculate stress from strain. You can calculate strain from stress. Right. So in both sets of equations, you will need to use the E and Poisson ratio, meaning that you can use either way, either directions, either sets of equations to solve these two components, these two constants. Okay, so here I want to adopt the strain to stress equations. Okay. So first of all, let's list these known values. Okay, the stress along X direction, 15 KSI. And that along the Y direction is 11 KSI. And epsilon X, the strain along X direction, is 530 microstrain, or 530 microstrain. Okay. Then the epsilon Y is 320 microstrain, or 320 micro strain. Okay. Here let's adopt the strain to stress equations. And as I said, this is a plane stress situation. Okay, so you just need to use the the plane stress equations. Okay, so the plane stress, the two equations will be epsilon X equals 1 over E sigma X minus nu sigma Y. And the second equation will be epsilon Y equals 1 over E sigma Y minus nu sigma X. Right? You just substitute the numbers in, so you will have 530 times 10 to the negative 6 equals 1 over E 15 minus nu times 11, and 320 times 10 to the negative 6 equals 1 over E 11 minus nu times 15. Okay, here you get equation 1, equation 2. Okay, so you have two equations, two unknowns. Obviously you can solve them, but what is the simplest way to solve them? Okay, so I got this. Okay, if you use 1 divided by 2. Okay, let's see what you can get. Okay, 1 divided by 2, you will get just 530 over 320 equals, since this 10 to minus 6 will gone, and 1 over e will also gone. Okay, you will only get 15 minus 11 nu over 11 minus 15 nu. Okay, so here you only have one equation, one unknown left. Okay, based on this, you can derive that the nu equals 0.2325. And substitute this number into either equation 1 or equation 2, you can solve the e. Okay. The e is 23466 KSI. Okay. So far we have solved these two constants, this Poisson ratio and modulus of elasticity. Okay. Do you think you can also solve it using the other direction? The other direction, I mean the other direction here. So you can have the stress to strain equations. You can also use the stress to strain equations. Right. So if this is plane stress, these two equations will be sigma x equals e over 1 minus nu square epsilon x plus nu epsilon y, and the sigma y equals e over 1 minus nu square epsilon y plus nu epsilon x. Okay, so you get these two equations. Do you think you can solve the nu and e in a similar way? Please try this by yourself.